Geometry and Nature by Ray Zhang and Adrian Wong.
Before we start our presentation, we would like to share this interesting and relevant quote. I think the universe is pure geometry, basically a beautiful shape twisting around and dancing over space-time. Anthony Garrett Lisi. We think this quote clearly expresses how the universe, so nature, corresponds with geometry.
So, we will first talk about geometry's importance in nature, then we will talk about hexagons, tessellations, the Fibonacci sequence, the golden ratio, symmetry, and circles and spheres. Lastly, we will talk about the conclusion, and we're excited.
Geometry is important to nature. In this universe, nothing would exist without geometry. Without geometry, the universe and nature would be, well, shapeless nothing. Everything in nature is the shape that is for a reason. Living things have passed through millions of years of evolution, which makes the geometric components in the most optimal. Non-living things receive changes in geometry through forces such as tension or erosion. Everything we know about mathematical geometry right now is from studying and observing the geometry in nature. Every shape, every angle, every formula all started from natural geometry. From animals to rocks, every natural object, geometry is incorporated in some way or another. A simple way to state this is that geometry shapes nature clearly. Therefore, geometry is a huge asset in how nature functions and is perceived.
Let us start by talking about hexagons. Hexagons are a regular polygon which consists of 6 edges and 6 vertices, with each vertex having a 120-degree angle. The hexagon is widely thought of as the most common shape in nature, with the circle also being a likely contender. Hexagons are found everywhere in nature. Look around. Can you see any hexagons in your vicinity? Even if there are no natural hexagons around you, the light-catching cells in the back of your eyes are hexagons. The reason why hexagons are so prevalent is because of the shape's efficiency. On a flat plane, there are 3 shapes that are able to completely fill out the space with no gaps. These being the triangle, the square, and the hexagon. Out of these 3 shapes, the hexagon encases the most area for least amount of perimeter. This makes it the most space-efficient shape on a flat plane. This is put to good use in many different places. For example, the shape-centered insect size evolved into a hexagon shape due to using the least amount of cell material for the most amount of light-catching area. Expanding on this topic, we are able to find different examples of this, such as bubbles, basalt columns, and the infamous honeycomb. Bubbles are layers of liquid surrounding air. On their own, they are spheres due to it containing the most amount of volume for the least amount of surface area. This is because of the surface tension wanting the outside to be as small as it can, and the air pressure from the inside wanting to push out. However, when bubbles are combined, they will form 120-degree angles, so a hexagon. This is because the 120-degree angle is the most mechanically stable arrangement. This directly translates to how basalt columns are formed. Cooling magma that shrinks due to cooling resulting in tension. Cracks form to release the tension at 120-degree angles, due to it being the aforementioned most mechanically stable arrangement. Same for snowflakes. When water molecules cool, they tend to arrange themselves into hexagons, which results in 6-sided snowflakes. Graphite, a form of carbon, has its atoms in a hexagonal structure, making it an incredibly strong material. Honeycombs are a combination of these 2 reasons. Wax is hard for bees to make and require a lot of pollen to make, so they want to use the least amount of wax to cover the most amount of area, so they chose circles. However, from the heat of bees working, the wax melts into hexagons, reaching mechanical stability. We can assume that nature prefers efficiency, therefore choosing hexagons. This is more of an interesting fact and doesn't relate to the above reasons, but Saturn also has a hexagon in it, rightly named Saturn's hexagon. On Saturn's North Pole, there is a huge cloud that resembles a hexagon. Scientists are unable to explain why it is specifically a hexagon, so this stays as one of the solar system's greatest mysteries. Therefore, due to all these reasons, the hexagon is arguably the most prevalent shape in nature. In nature, there are a lot of patterns. How nature shows these patterns is in tessellations. A tessellation, or tiling, is the covering of a plane using one or more geometric shapes with no overlaps and no gaps. There are many different types of tessellations in nature, some having regular polygons, others having more complex shapes. An example of the former is once again the honeycomb. The honeycomb is a tessellation of hexagons repeated over and over again. Same with the pineapple. Looking closely, we can see that the individual units on the skin are actually hexagons, and that also forms a tessellation. Fish skin is a tessellation as well, as all of the scales tell neatly. Another is the middle of a sunflower. The seeds arrange themselves to become a tessellation as well. These are all examples of tessellations with relatively the same shape, but there are ones consisting of different polygons. If we were to look closely at a dragonfly wing, we are able to see a tessellation, closely resembling something like cracked glass, with different individual shapes. Tessellations are absolutely everywhere in nature. The Fibonacci sequence is one of the most mysterious things in nature. The Fibonacci sequence is a sequence of numbers, in which a number is the sum of the two previous numbers, resulting in the sequence of 1, 1, 2, 3, 5, 8, 13, and so on. On its own, it doesn't have anything to do with geometry, but the most important part is the Fibonacci spiral. By plotting squares with the lengths of the numbers in the sequence and drawing a spiral within them, something extremely interesting appears. We are able to see this spiral in many instances in nature, the most well-known being the Nautilus shell, along with things like aloe plants, pine cones, flowers, and even the Milky Way itself. The golden ratio is widely known as the most beautiful number in the universe, and for good reason. The golden ratio is everywhere in nature. From the distances between the planets to the human body itself, the golden ratio is there. But what is this golden ratio, you ask? Two numbers are in the golden ratio if their ratio is the same as the ratio of their sum and the larger number. This results in a non-terminating number that is approximately 1.618. The golden ratio is commonly associated with the Fibonacci sequence, as if we divide a number on the sequence by the number preceding it, it will be around the golden ratio. The greater the number, the closer the golden ratio. Take, for example, the number 377 and 233. Both numbers are on the Fibonacci sequence, and 377 divided by 233 is around 1.618. Now that the explanation is out of the way, we can start talking about examples. The golden ratio is largely prevalent on the human body. Some examples are the tip of the finger to the first and second knuckles, the tip of your hand to the wrist to the elbow, and from the top of your head to your belly button and to your toe. All of these and many other examples all equate to approximately 1.618. We're able to take the scale up a lot until we can see the entire solar system. The distances relating to the Sun to Mercury to Venus, or Venus to Earth, etc. is around the golden ratio. This shows how important and how prevalent the golden ratio is in nature.
Symmetry in nature appears a lot. There are three main types of symmetry that you can find in nature. The first is bilateral, more commonly known as reflection. This type of symmetry is where there's only one symmetric line. This kind of symmetry is found mostly in animals. For example, on a butterfly, there could be only one possible symmetric line on it, from top to the bottom. This is the same for humans, tigers, bugs, you name it. It is called reflectional, because one side of it is the mirror image or reflection of the other side. The second type of symmetry is radial, more commonly known as rotational. Rotational symmetry is where there are multiple lines of symmetry. The object will look the same after a partial turn. For example, the displayed firm has multiple lines of symmetry, and if one were to turn it, it would look relatively the same, as every time there is a rotation, there would always be a symmetric line. Other examples are snowflakes, starfish, flowers, and coral polyps. The last type of the main types of symmetry is translational. Translational symmetry is when a pattern or a design is made by sliding or moving an original figure repeatedly. For example, honeycombs are tessellations of hexagons, repeating the same hexagon shape over and over. If you were to take a bigger photo, the image shouldn't have a different pattern. Other examples are aloe vera and the middle of sunflowers. In the end, symmetry is a fundamental part of geometry and can create patterns to help us organize our world conceptually. The examples above were little examples of symmetry, but looking at the big world, there are larger examples when compared to the ones I showed. Lastly, I'll talk about circles and spheres. The circle, along with its 3D counterpart, the sphere, are one of the most common shapes in nature. This is due to the circle and sphere being the shapes which covers the most area/volume for the least amount of circumference/surface area. And from the hexagon slide, we can assume that nature prefers efficiency, and these shapes happen to be the most efficient. Some examples of circles that are found naturally include celestial bodies, atoms, bubbles, the human eye, and oranges. Celestial bodies such as Earth or the Sun happen to be spheres due to gravity. Gravity pulls equally from all sides, and a circle has the same radius everywhere. On the extremely smallest scale, atoms follow the same principle, just with a different force. Instead of gravity, it is called electromagnetic force, from the proton to the electron holding it together. The electron orbits around the nucleus, and same with gravity. Electromagnetic force pulls equally from all sides, resulting in a spherical shape. The reason why bubbles are shaped like a sphere is that the attraction of molecules, called surface tension, contracts the soap bubbles to the smallest possible area. At the same time, the air inside the soap bubble presses against it as air pressure. The bubble forms into a sphere because it can contain the most air pressure with the least amount of tension. The same principle applies to the human eye. The fluid that flows in the eye is called aqueous humor. The outward force from the fluid is isotropic, equal in all directions. The inward force of the surface tension in the outer shell of the eye is also isotropic. The balance between these inward and outward forces determines the spherical shape of the eye. For an orange, the reason why it's spherical is that the plant cells are spheres. The plant grows from the inside, which expands into a larger sphere. Overall, geometry helps nature make sense in our world. Due to the above reasons, geometry is a crucial part of nature. Things occurring right now wouldn't be existing if it was not for geometry. Ray and I were very interested in researching or looking in more depth about geometry and have learned a lot from this learning experience. Thank you for listening to our presentation.